Hello students, welcome back. Today I am going to solve few numericals from chapter 5a, exercise 5a. Okay, so these are the numericals in page number 105. First one is a body of volume 100 centimeter cube weighs 5 gram force in air. It is completely immersed in a liquid of density 1.8 into 10 to the power 3 kg per meter cube. Find the upthrust due to the liquid and the weight of the body in the liquid. So the values given in the question is volume is 100 centimeter cube, weight of the solid in air is 5 kilogram force. If it is completely immersed in water, then in a liquid, not in water, in a liquid of density, that is rho, 1.8 into 10 to the power 3 kg per meter cube. So first of all, we need to find the upthrust due to the liquid. So to find the upthrust, the formula is volume volume of the solid multiplied by density into acceleration due to gravity. Volume of the liquid is 100 centimeter cube. This has to be converted because this is in terms of kg, this also in terms of kg and meter cube. This has to be converted into meter cube. So it will be 100. Whenever we convert centimeter into meter, we divide it by 100. But if it is 3 centimeter cube means 3 centimeter, then you have to divide by 300. Okay, 3 different hundreds. So it will be 100 into 100 into 100. So this can be written as 100 into, if you count the number of zeros, it is 6. So when we take this in the numerator, you can write it as 10 to the power minus 6 meter cube. So this will be the volume, 100 into 10 to the power minus 6 multiplied by density is 1.8 into 10 to the power 3 multiplied by g. G is not given. So if you multiply this, how much do we get is 0.18, and in the unit upthrust is force. We can write Newton, but we are going to write kgf, that is kilogram force, where g is included in the unit. This is the first part. Now for the second part, you need to find the weight of the body in the liquid. So weight of the body inside the liquid. Whenever we put a solid inside a liquid, the weight will be reduced. So it will not be as same as before. So weight of the body inside the liquid will be actual weight minus upthrust. So what is the actual weight? Actual weight is 5 kgf. 5 kgf minus upthrust is 0.18, which equals to 4.82 kgf. This is for question number 1. Now let us move on to question number 2. Question number 2 is a body weighs, I'll write it down what are the things given as I read the question. Okay, the body weights means the weight of the body is 450 gram force in air and 360 gram force when immersed in water. Inside water, the weight is reduced, which is 310 gram force. So, okay, these two things are given in the question. Okay, weight when it is outside the liquid, and weight when it is inside the liquid. And density is given, that is assumption density of water is 1.0 gram centimeter cube, gram per centimeter cube. Now first part of the question is the volume of the body. You need to find the volume of the body V. So volume of the body will be loss in weight. Okay, actually formula of volume is mass into density, or weight into density. So which weight we are talking about? The weight, the difference which is given. Okay, loss in weight. If it is actually 450, when we put in water it becomes 310. So if you subtract this, we get the loss in weight into density is 1.0. Now when you calculate this, first of all we subtract, then we multiply, we get 140 centimeter cube. This is the first part. Now second part of the question is the loss in weight of the body. Second part, you have to find loss in weight is equals to initial weight, which is outside 450, and the weight after we put inside the liquid, that is 310. So difference in the weight will be, if we subtract this, we get 140. Unit of weight is gram force. Now the third part of the numerical, that is the upthrust on the liquid. So third part is you have to find the upthrust. Upthrust is equals to loss in weight. Whatever is the loss in weight, that is our upthrust. This is from Archimedes' principle. It states that the loss in weight of the body is actually equal to the upthrust or the upward force. Now what is our loss in weight? It is 140. So upthrust will also be 140 gram force. This is for question number 2. Now I am solving question number 4. In this chapter, only the basic numerical is required, which is from Archimedes' principle. So we are not going into the complicated ones, just simple basic numericals. So question number 4. Question number 4 is a solid of density. I'm writing this way. Density is rho. If it is solid, I'm writing S. The density is 5000 kg per meter cube. Weight of the solid is 0.5 kgf, is in air. That is the density and weight in air. After we immerse that in water, now the density of water is 1000 kg per meter cube. This is the density of water. Now what you have to calculate is, you have to calculate the apparent weight of the solid in water. When we put this solid inside the water, the weight will be reduced. If it is this much initially, after putting inside the liquid, the weight will be reduced. Now to find the weight, first of all we need to find the upthrust. Upthrust will be volume of solid multiplied by density of liquid multiplied by G. Now volume of solid is, the formula of volume is equals to mass divided by density. Okay, it is actually mass or weight divided by density. So I write down the value. Weight of the solid is 0.5, density is 5000, density of water is 1000 multiplied by G. Now if we do the calculation, we get 0.1 kgf. After finding the upthrust, next we have to find the apparent weight. So now apparent weight is equals to true weight minus the upthrust. True weight is 0.5 minus upthrust is 0.1, which equals to 0.4 kgf. This is question number 4. Next, I will solve question number 7. Okay, this will be the last question which I am going to solve. Question number 7. Question number 7 is, a piece of brass weighs 175 gram force in air. So the weight of brass is 175 gram force. Okay, it is 175 gram force in air. Now, and 150 gram force when fully immersed in water. When we dip that brass inside water, the weight reduces to 150 gram force. So same weight of brass inside water is 150 gram force. The density of water is 1.0 gram force. So density of water is 1.0 gram per centimeter cube. Question is, what is the volume of brass piece? To find the volume of brass piece is equals to, actually it is the loss in weight. Whatever is the difference of the weight, that is the volume of the brass. So to find the difference, we just subtract these two numbers. 175 minus 150 is equals to 25 centimeter cube. This is the volume. Second part is, why does the brass piece weigh less in water? So why does the weight changes in water? Because it is due to the upthrust or the upward force of the water. Okay, this is the reason. Try out rest of the numericals. If you have any doubt, please do ask. This much for today. We'll continue in the next class. Thank you.